My name is Rodríguez Hernández and I am from the Universidad Autónoma del Estado de Puebla. The focus of my research, titled Enhancement of Electrical Properties of Cold Welding Doped Using CNTs, is on enhancing, the electrical properties of these joints, incorporating double-walled carbon nanotubes, or DWNTs, into epoxy adhesives. Cold welding is a crucial technique for joining materials without the application of heat, which helps prevent thermal deformations. However, welding aluminum poses a specific challenge due to its thermal conductivity and the formation of surface oxides. These factors complicate the traditional welding processes, making epoxy welding a more effective solution. For this study, we prepared a total of 40 samples using 6061 aluminum rods, which were cut into segments with a diameter of 11 millimeters and a length of 50 millimeters. The rods were then polished to ensure a uniform surface. We joined these rods using an epoxy adhesive, specifically the Depcon 342, which we doped with the double-walled carbon nanotubes at different volumetric concentrations, being 0%, 0.01%, 0.03%, 0.05%, and 0.1%. After applying the adhesive, the samples were left to dry at room temperature for 36 hours, and then they were exposed to a sulfok chamber in accordance to the ASTM B117 standards at intervals of 0, 4, 7, and 14 days. The electrical resistivity of the joints was measured using a 4-point probe method, which allowed us to accurately assess the resistivity while minimizing the effects of contact resistance. Our results show that the incorporation of DWNTs into the epoxy adhesive significantly affects the electrical resistivity of the cold weld joints. Initially, at time 0, the resistivity varies slightly across samples with different concentrations. However, as the samples were exposed to the salt chamber over time, this difference became more pronounced. Notably, the 0.05% DWNT concentration was the most effective, showing the greatest reduction in resistivity over time. After 14 days of exposure, the samples with 0.05% DWNTs demonstrated a significant decrease in resistivity compared to both the control samples and those with another concentrations. Also, after that, we performed an ANOVA on the resistivity data, which confirmed that the difference between DWNT concentrations are statistically significant. This supports the hypothesis that the optimal concentration plays a critical role in enhancing the electrical properties of these joints. These findings suggest that there is a delicate balance in the concentrations of double-walled carbon nanotubes needed to optimize the electrical conductivity of the epoxy adhesive. At lower concentrations, such as 0.01%, the reduction was less significant, indicating that the quantity of nanotubes was insufficient to form an effective conductive network through the adhesive matrix. On the other hand, higher concentrations, like 0.1%, did not significantly improve the resistivity compared to the 0.05% concentration, likely due to the agglomeration of nanotubes, which can limit the formation of an effective conductive network. The consistent reduction in the resistivity at the 0.05% concentration over the 14-day period suggests that double-walled carbon nanotubes not only improve initial conductivity but also provide a long-term stability under harsh environmental conditions. In conclusion, this research demonstrates that the incorporation of 0.05% DWNTs into epoxy adhesives significantly optimize the electrical conductivity of cold weld aluminum joints. These improvements are maintained even under challenging environmental conditions, such as prolonged exposure to the sulfur chamber. These findings provide a strong foundation for further research aimed at optimizing composite materials for applications that require high electrical stability in adverse conditions. The potentials of double-walled carbon nanotubes in enhancing the performance and reliability of cold-weld joints in industries is significant. Thank you for your attention, and I will be very happy to answer any questions that you could have.